Today we have a problem, that is to reverse the a 32-bit signed integer, uh, and uh, and if the value goes outside the range of a 32-bit signed integer, then we have to return zero. The problem seems simple, but it has a very low acceptance rate. Today we'll try to solve this problem. So let me uh, open Notepad and explain my approach with you. So first of all, the our approach is first reverse the integer to. So basically, what we will do is we will save the value of previous integer, previous sum, and uh, minus um, current digit divided by 10. That should be equal to, sorry, uh, current sum. Sorry for the mistake. This current sum. So basically what we'll do is using our normal approach to reverse a digit, which is basically uh, calculating the sum uh, of a number multiplied by 10, and then adding it with the modulus of 10 of the current digit, current number. So we will generate the current sum. So let me show you how we will generate the current sum. So the current sum will be equal to now plus now modulus 10. What we'll do is we will be subtracting the current digit, basically current digit. Digit is basically num modulus 10. So we will be subtracting the current digit, uh, current sum with the current digit, and when we divide it by 10, this should be equal to the previous sum. So uh, basically reverse num is the number that we are currently generating it from zero. Yeah, it's basically 0 in the beginning, and then we will run a while loop while loop num is not equal to 0. So till then we will do this, and uh, so we will be checking it in the if condition. It's not equal to this this. So in that case, uh, overflow is uh, so this will be our approach, and then we'll be returning to 0. So this will be some garbage value if we do not return 0. So in that case, so this will be our logic for the whole program. So let us code the solution here. So rule to if x is less than 0, and in that case, less than 0, then x is equal to minus of x. Okay. So basically, we do not want to perform operations with the negative integer. So uh, also will be negating the number. So one step, uh, we will be uh, making the value of negative flag is equal to in the next step. Development is equal to 0 and uh, we have to progress of calculating statement. Now we will turning of like y x is not equal to 0. In that case, so digit um, some two one so once and modulus sorry self things first of all take of the current digit that will be equal to x scan. So this will be the current digit and the next step will be adding the current digit uh, we can statement of some yes. Then yes, This is not correct. So in that case, yes. Um, please, accept it. Just try something. What? Okay, so friends, like with our approach, we have run into a problem. Which is, in this step, if we ram num into 10, value is greater than the value of int max or the limit of the integer 32-bit integer range, then in that case, we cannot uh, make sure that this cannot be an integer value. So what we'll do is we will add a check here that before calculating the reverse name. So we'll basically add a check here. So what we'll do is if um, have num to 10 is greater than, sorry, ram num is greater than int max by 10. So basically, what is the idea behind this step is we are calculating the RAM num by multiplying it with 10, and that is the step where our approach fails. Like multiplying it with the 10 will leave if it exists. If uh, so, this is common mathematical formula. It is ref now into 10 is equal to into x is equal to into x. So, if we divide into x by 10, then it will be equal to rem1. So if rem1 then none is greater than into 10 greater than 20x, then then rem1 will be greater than in max 10. So this is simple mathematics. That is not a big approach. So let us employ this approach here. So if we should do it for calculating the current sum. So if RAM now is greater than max by 10, and then we will be simply copy pasting this line. Stop. Now let us start to submit our solution. So like we have passed 1043 test cases, like we are very close to the solution here. So indication of getting a runtime error. So now we need to totally change our approach here. So basically, what we have encountered the problem here is that the negation of this number like cannot be represented in uh, as an integer. So basically, the
But I've
step
always
which we
used
have,
to capture my
so we need to basically change the step. So just remove all these things. We don't need it actually. So let's keep it simple. So maybe let's remember the value of 9, but actually, so, so now we will have to add an extra condition. So this extra condition, um, I think we need to change the whole program here. So let us try to create a number, tries of 0, and then this solution. And let's calculate the remainder. 1 equals to x plus 10 It's 10. Uh, and, it's equal to it's provided. Now in this step where our process is if um, if there's this then in its if this new live unlimited case we have and in that case we don't see additionally we can line just for decorating our code. It's, exactly. Yeah. We want to say we have like this when this code we should not I think that we must slightly we missed the part where we need to and update the value of um, 10. Um, just remind that for this condition as well. Now let us submit it code. So that was a syntax error. We forgot to put the semicolon here. Now let us run our solution. Okay, so while coding, we forgot to put divide by 10 here. So this should actually pass. So our problem has been accepted. So, so like it needs 100%. You can see uh, so you can see like our solution has passed all the test cases, all the 1045 test cases, and it beats 100% uh, all the solutions. So thank you guys for watching this video. I hope you enjoyed learning. Thank you guys.